Here we have Atomik server, and we are going to do a little test involving vital signs. So we created 1,000 EHRs. We have 20 documents with vital signs monitoring data in each EHR, and we are going to query. So just an overview. Here you have the dashboard. You can see all the EHRs you have. You can see the people. This could be patients, because this is also a demographic repository. Patients, doctors, physicians, etc. We can have also data about organizations. We will work with queries too and templates too. Yeah. So for the EHRs, we are going to check, for instance, here you can see all the EHRs in the system. One clarification, Atomik is a server for administration of data. It's not the final EMR or EHR that clinicians will use. Yeah? It's just a way to store your data and to manage the data. And this user interface is for administrators. It's not for the end user. It's not for the clinician. Yeah, it's not for the nurse. Here we have one EHR. We have some changes to that EHR in a timeline. We can see the details of the changes on this view. The changes to an EHR are called contributions. And you can see each change to that specific EHR. And we can grab one, and we can see that we have a contribution that contains a document. That document is for vital signs monitoring. So we know that this EHR actually contains data for vital signs. Yeah. And we can actually see the data. This is the actual document that was committed by a client. And the client is the clinical application. So you might have an EHR, an EMR, a mobile application. You can also have, for instance, a mobile application or a web application that can be used by the patient, and the patient could create records for himself, herself. For instance, vital signs monitoring, sometimes physicians give the patients some wearable devices, some sensors, and they can actually use the sensors to measure different, blood pressure, heart rate, etc. And that data can be transformed to a valid OpenHR document, a composition, and we can use that to send, to Atomik and to store that in Atomik. So now that we know we have data, we will go to templates just to show you. Here we have the vital signs monitoring template. The template is basically the definition of the data that will be in a clinical document, for instance, the vital signs monitoring document. If we click here, we can see some data about the templates, the versions. We can upload different versions of the same templates. And this is the definition, is an XML. We will change this in the future. We'll use only JSON. But for now, this is the canonical standard format for templates in OpenHR. For instance, we can search for systolic, and we can check that systolic is defined here. And if we search for the code, because OpenHR uses codes to define the nodes, this is the node that defines the systolic blood pressure record, the data point. Yeah. And you can see, for instance, a constraint for the range, a constraint for the units. So this is the range for the magnitude, the number, and this is the units. This is millimeters of mercury. So blood pressure is measured in millimeters of mercury. Yeah, and all the data points are defined here. Here we have blood pressure, heart rate, oximetry, we had weight, we have body temperature, etc. Everything included in the same template. And we use the template to validate the data that is sent from clinical applications to Atomik, to index the data so it can be queried, and also to create queries. And the query creation is just a way to extract information that is stored in Atomic, is done using user interface. So you don't need to know how to code or how to create SQL or some specific language to create the query. You just need to know how to point and click, and I will show you how to do that now. Before I go to create a query, here you can organize the query in groups, and here you can create new groups, and you can have, for instance, several queries related with vital signs, and you can group all the queries in a vital signs group here. You can also upload a query, and you can download all the queries and upload all the queries. For instance, if I click here, it will generate a compressed file with all the queries I have here. And if I have another Atomic server running in a different server, physical server, I can upload that file, so I have the same queries in both Atomic instances. Yeah, so this is a very useful feature. I will create a query from scratch to show you how that works. So for instance, this will be, let's say that I want vital signs out of range. Yeah, and I will check, this will be just a test. I will check some vital signs that are out of range, and I will get as a result the document that contains those vital signs that are out of range. And document in OpenHR is composition, but you can also query for actors. This is when you store people, when you store organizations, you want to query for actors. Folder is the folder structure inside an EHR. Party relationship is when you want to query relationships between actors. For instance, if you have an organization and you have a doctor, then you can say, this doctor works in this organization, in this hospital. Or if you have a doctor and you have a patient and you want to say, this is the reference, doctor, physician for this patient, because the doctor is treating a specific case on that patient, a specific illness, you will go to party relationship. And role, you can also query roles. Roles are roles that are assigned to different actors. So you can have a person that is a nurse. Nurse is the role. A person that is a physician. A person that is a patient. Yeah, all of those are roles. We'll query for compositions, so documents, and this will actually get and list all the templates that we have in the system. Remember, templates is the definition of the data, basically the schema, if you think of relational databases. And here you have all the templates that are defining compositions. And we should have here vital signs monitoring V1. This is the one that we want to use because it's the last one I created for testing. We have other tests here, but we will use the last one. And here you can see the internal structure of that template. And you can see that that contains body temperature, blood pressure, body weight, oximetry, pulse, heart rate, and respiration. Yes, this is for the respiration rate. So we can select one of these structures. Those are called archetypes, and that is the idea of the archetype. And we can see all the data points inside that specific concept. Yeah. So for instance, in blood pressure, we can see systolic, diastolic. We see the position of the patient at the time we record the data, the sleep status, if the patient is asleep or not, etc. So for systolic, we can select that point and we can define a condition. And we will define a condition that, for instance, systolic is out of range. So let's say systolic magnitude is greater than 140. Yeah. We can also define a variable for the value instead of giving a fixed value, because on some countries, even 130 is considered out of range. It depends on the guideline that you follow. So if you define this as a variable, you can actually use the same query in different contexts. Right? But we will consider that is our out of range upper out of range value. So we can add the condition, and this says basically systolic, that is a quantity and should have the magnitude greater than 140 and the units equal to millimeters of mercury. Yeah, so that is our condition. We can do the same with the, I click in the wrong, this. With the systolic should be greater than 90. I will add the condition, and then I have two simple conditions. I can say an or between them. Yeah, I can also go back and say, for instance, let's grab the pulse heartbeat. Yeah, this one. The rate for the heart should be greater than 100 beats per minute. Yeah, and I added the new condition here. So we have rate for the pulse that is greater than 100 beats per minute. And we can also combine these two as an OR. Yeah, and that way, with just clicking on things that we kind of understand, this is a document definition, these are specific clinical concepts, these are the data contained in those clinical concepts, and this is basically a condition over the data, and the condition will depend on the type of the data. Yeah, for instance, we have different operations to compare, you know, our data with a given value or a variable. Yeah, and that way you don't need to know about the technical details behind this. You just point and click, and you with a little logic, yeah, operation here, you know that it should comply with this condition or this condition or this other condition. Yeah, it's not so difficult for someone that is non-technical. Yeah, and if you know about OpenHR, you know what all these, you know, strings mean. This is the definition of the blood pressure concept, and this is the path inside that definition that points exactly to this data point that is a diastolic value. Yeah, and the type of that data point is a quantity. Yeah, vital signs are all quantities. So I will choose retrieve data because I want the data back, and I can actually create the query as it is, yeah, or I can test it with live data. And as I said before, I created 1,000 EHRs with 20 records, documents with vital signs for each EHR. So I can just execute. If I don't give an EHR ID as a filter, this will be a population query. I will query all the EHRs in the database. Yeah, so I will execute the query, and I will see some results there. So the results is basically a list of records. Each record contains the document here in the local table key, and also a header with metadata. The document is just vital signs monitoring with all the values. Yeah, systolic, diastolic, heart rate, etc. The metadata says to which EHR this document belongs to, what's the ID of the patient, so this points to the patient, and when this document was created in Atomik. Not when this document was created in the client application, in the clinical application, but the point in time when that application sent the document to Atomik. Yeah, that's this date. And if we search here, let's look for systolic. You can see that one document in the result has systolic 202. So this is higher than 140, the value that we set. So all the results will comply with our condition. Yeah, and if we go down to the bottom, we will see here the query response time. So it's around half a second. Yeah, this server is not warmed up, so we might get a small improvement in the performance. if we actually execute the same query a couple of times. One thing that we need to consider also is that this computer that I'm in is not a server, it's just a desktop computer. I'm running 1,000 different programs and processes, so this is shared memory. So this is not the best performance that we can get. Yeah, we can get better performance in a dedicated server. This is just for reference. Yeah. What I wanted to show you is that we can actually create data and we can query the data without writing a single line of code. That is value added by this server. And we also have this user interface that makes work easier. And if we do, one thing that I want to test with you here, filter by EHR ID, and we know that we have an EHR here, that contains vital signs. So I will just paste here, search, I will pick that one, and I will rerun. Now this should be filtered by that EHR. If you see the EHR ID in the metadata of this first result is the same as the value that I set there, and we should see a better performance there, because this is not a population query. When you do a population query, you are querying possibly thousands or tens of thousands of EHRs, and each EHR contains hundreds of documents. So you are basically querying the whole database. Yeah. When you constrain the query to run over an EHR, and that's a very common use case, because a clinician will, in a consultation, normal consultation, will be in the context of one patient and one EHR at a time. So in that context, a clinician can see just the data for that patient and just the data for the vital signs that are out of range for that specific patient. So this parameter for the EHID in most cases will be set. So in most cases, we will have a better performance, a better response time for the query when that is set. Also, if we constrain by time range, we can narrow that down to smaller, response time, because maybe you want to query just the documents for the last year, for the last 12 months. So if you don't constrain these, we are actually querying, even if we are querying a single EHR, we are querying the whole history of that patient that can be, 40 years in the past. So that is also common. So in general, we will filter by both date range of some kind and an EHR ID. Yeah. But when we do analysis, when we do population health, when we do public health, when we do reports, etc., we might want to do just population queries and remove this. But on those queries also, you don't have that constraint or necessity of a very, very fast response time, because also the system that is querying that data most of the time is a batch system, it's a batch process. It's not a user actually querying the data live. Yeah, but when we get a query that is for a specific EHR and a specific time range, that in general is a user using a system and wanting to see the data live at that specific moment in time. When we do population queries, it's something that we run, for instance, tonight to prepare a report for tomorrow. Yeah, so we don't have that kind of constraint there. So that is something that we also need to consider. Yeah, but in some cases we do need, live or real time queries that are population queries. Yeah, it depends on the client. Yeah. So what we do now is we can just create this query, will be stored in the database, and we'll store all the conditions that we just set. Yeah. So this is a very different way of working with a clinical data repository, because in general, with normal clinical data repositories, you need to actually create your queries in the code, and you need to recompile the whole system, and deploy the whole system again, run a lot of tests, etc. So it takes a lot of time, a lot of patience, requires debugging, requires people. Yeah, people should actually be doing that, unless you have some AI agents automating that. But with Atomik, you don't need anything of any of that, because you do that just pointing and clicking and saving, and that's it. Your query is here. If your query is here, you can actually go to the REST API, use this ID, and just execute the query from the API. So basically, you just added in a couple of minutes a new service to the system that is available through the REST API, and you didn't touch a line of code. You didn't need to rebuild the system, recompile the system, redeploy, do a lot of tests on the system itself, yeah, because you didn't touch the code. This is something that is stored in the database. I mean, the query is in the database too, yeah? And we can, for instance, export the query, and this is the format that we use for doing backups of the queries or synchronizing the queries between different instances of Atomik. Yeah, and this is basically that. All the conditions are here. Yeah, so we don't rely in the syntax for defining the queries. We have in OpenHR AQL. AQL is basically a query language for OpenHR data. And this specification is focused mainly on the syntax, on defining how the query should be written. Yeah, so this relies on this specific syntax. Yeah, it's a kind of a domain-specific syntax based on SQL, but adapted to how OpenHR works. And for a long time, I didn't like the idea of focusing a lot on the syntax, because what is meaningful is really how this works. What is this doing behind? And the specification doesn't focus on that part, the part of the execution, of the processing, of how the query should be interpreted and how the results should be structured. We focus mainly on that, on how to process this, and less on the syntax. So basically the syntax is just a JSON, but it could be anything. Could be an XML, could be a YAML, could be anything. Yeah, but we have this syntax, and we also created a mapping to AQL. So we are maintaining our internal query model, but we can also generate AQL. And the type of AQL that we can generate is a subset of all the things that AQL can do. Yeah, because we implemented logically a subset of the functionality that you can obtain with AQL and executing what the spec allows you to execute. So we just have a subset of this, but in the future we will have the full thing mapped one by one to our internal model structure. For instance, we don't support contains just yet, but this will come. Yeah. So right now I can create my query, point and click. I don't need to write this thing. I don't need to worry about any of these technical details. I just point and click, add things, define the conditions, and then I can export the AQL. So we have a subset of AQL. This AQL will work on other OpenHR CDRs, yeah? And it's basically saying this has the same meaning as our model. So we are selecting compositions from an EHR. We are not constraining the EHR, so this is any EHR. The EHR contains a composition that complies with the vital signs archetype. And this composition should have an observation O for blood pressure, or an observation O1 for pulse, and the O is the conditions for the blood pressure. So we have this path that points to, now we know, systolic blood pressure and should be bigger, greater than 140, Or we have also diastolic should be greater than 90, yeah, and we have the and to the units, so we know the units come with the condition for the value. Or we have these ors we define it in the query. We have O1, so this is for the pulse, and this is the pulse rate basically, is greater than 100, and the units should be beats per minute. Yeah. So we know that we can translate between our query model and AQL. And we can do this also. We can copy the AQL, and we have actually an AQL endpoint in the API, even though we don't implement AQL directly. We have a mapping between our model and AQL. We can paste the AQL expression. I need to remove the all the formatting here, so we have a small application here. So we need to remove, this is the same query, yeah, it's just compressed, it's just one line, yeah. And if I execute this AQL, and this is compliant with the OpenHR REST API and with AQL itself, yeah, I will execute, and this, what this will do is, it will do the opposite thing. It will do the translation, there it rendered, the translation of this AQL to our internal model. It will execute our internal model, query model. So it will be the same query as I showed you before. And this is the result that I showed you in our testing. So it's basically a list of results. The data is in the local table key. So this is the document, but you also have metadata. So you also have an EHR, a subject, and the time created for that specific document. And here you can see the response time. This response time is, the whole thing is parsing the AQL, mapping that AQL to our internal model, generating from our internal model a query, so it will be kind of a SQL query, it's similar to SQL. It will execute, it will return the result, and it will render the result as a JSON and deliver that to the client. So everything takes less than 4 seconds. Yeah, and if we execute a couple of times, we might get smaller response times because of caching. We might get, it depends on so many factors. But all of that is done live. So we are actually, this AQL, we are parsing that and mapping that. So we got slightly the same response time here. Let's see if I can provide the EHID here. Let's check if I do. I didn't test this, so just bear with me for a second. Let's see if that works. I think I changed, this is EHID, I think. Give me a second. This is an old request I reused. EHR UID. I don't remember this part. I need to I need to check the documentation. Yeah. No. For AQL, the way of sending the EHID is different. I need to do something in the query itself. But anyway, I will debug that later. I just wanted to show you that we can add parameters, but I don't remember right now how those parameters work. Yeah, I think, let's check the REST API. Because I want to know this way of sending the EHID is actually the way we use for our normal queries, our internal model of queries. But for AQL is different. Let's check. Ad hoc queries. Let's check if this works. As I say, I didn't test this, so it should be in the body, not in the parameters. HR ID, I think it was this thing, this way. And we will have this ID. Let's see if this works. If not, I will do another video showing you how to pass parameters to our queries. So let's just check that. And yeah, that worked, because I see in the result that the HID, you can see it here, the HID is just what I passed. Yeah, oof, that worked. We are lucky. And you can see also that the response time is actually half of what we got before. If we send that twice, it's around 250 and 300. That was slower because I'm executing a lot of things here, so this is smaller. So this is kind of the smallest time we got back. So it's about 150 and 300 milliseconds, around that, I would say, the normal response time when you filter by EHID. Yeah. So I wanted to show you that actually, so you can do, some kind of AQL subset. Works perfectly in Atomik. We are still going to do some changes to support the contains. This won't take a long time, but right now we are working on that. So we'll have news soon. Also, if you want to see something specific about Atomik, something that you want to explore, anything from the user interface to the API to the configuration, synchronization, more about queries, you can just leave me a message and we can chat. Yeah. One thing I can show you in another video is how to, instead of getting full documents, how can we retrieve just data points from documents. Yeah, we can do another query with that. But for now, that's all I wanted to show you. So thank you very much for watching, and let me know what you think. Yeah, talk later. Bye-bye.